I really think everything started from the baby steps. So, welcome to year 12 physics, module 5. Yahoo! Finally, I can start this short topic. It's called the advanced mechanics. So, the reason why it calls the advanced mechanics is obviously you need to know all the mechanics that we learned in module 1 and 2. I'm talking about all that motion equations, motion graph, all the Newton's law, energies, and sometimes momentum as well too. So I will probably going through some of the revision as we go through too, and so make sure like you're following to the track. So let's revise some things that we learned in year 11. So in year 11, in mechanics in module 2 and 1, we learned about something known as motion formulas or the motion equations. All right. Damien, can you give me some motion formulas or equations that we memorized? Yes, you.
V equals U plus AT.
Yeah, V equals U plus AT, that's 1.
S equals UT plus half AT squared.
Half AT squared. Now, time to times we put the delta S because that's a change in like positions. We call it displacement. Last one?
V squared plus U squared equals 2A.
Yes, equals to 2AS2. These are the kind of called the general motion equation. That's all you need to know. If I add more and more, the acceleration is always be delta V on delta T, which is we know that V minus U over time taken, find the gradient values. Not difficult, even a single bit. Now, how about we combine that to this one in here? So let's talk about vertical motion. Joseph, can you tell me about what's so special about the vertical motion on Earth? Let's talk about Earth, like vertical motions. Okay, so we always get the acceleration, that is the minus 9.8 meter per second squared. Now, using the direction convention, this can be rewritten as 9.8 meter per second downward. Always do. Okay, that's called the gravitational acceleration. So sometimes to times it is also given as minus g. Remember that g is not the acceleration, g is the constant value, which is 9.8 meter per second squared like this. Okay, then the negative is something that I'm telling you about what the direction, so going downwards in that case. Anything else? I kind of talked about it, so as I know, this is the information get hidden, but also be given from the vertical motions.
At max height, the final velocity is 0.
Good. At the maximum height, we know the final velocity is 0. Because when something goes up, it looks like it's stopped and it's coming downwards too. Okay? Generally, when we start with the same height, but in some same height, we also know that when it's coming to the U, it comes down into the minus U in the same magnitude as well too. This is kind of third assumption in a case that if by ignoring the air resistance. Now, time to time, you may need to count what the air resistant values to. But here, I'm not really talking about forces yet. There'll be gravitational force applied, which is the weight forces that will be applied to. Okay? These are the two information we're given, but the hidden two. Now, let's talk about it here. Vertical motions, also known as something that vertically, it's a y-axis. So I got to put the y-axis like this. So instead of to differentiate the vertical motions to the other motions too, I may put some y like that, giving us the ay equals to minus 9, or that's giving you the minus g here like this value. Same for the vertical motion at maximum, the vy equals to 0 here, the forms too. Okay, now what about we have the horizontal motion? Horizontal motion. Simply means when something is moving along with the horizontally like that. In a case of that, and horizontal motion without, if there is no zero, net force applied in here. Or if there is, in other words, if there is no resistance in the motion. Guys, what happens if you have a zero net force or no resistance in the motions? The motion, according to Newton's first law, where we learned to measure to, we're moving in the same speed and same direction all the time. So there will be, this would have there be no, the acceleration applied would be 0. If there is no acceleration, no force applied in here or no resistance applied. This means that the net force will be 0 too. So to differentiate to the vertical motion on the y-axis, we got to put into the x-axis, and then I got to put the ax to be 0 forms like that. Okay, that's the second information we got to use, and you can copy this down on the in class as 1.1, and this is what the Galileo explained, used to explain the motion called the projectile motions. We're going to talk about more about projectile motions today as we go through. So what we need to do first is page 3, please. Let's have a look at the some example questions that we've done in year 11. It's something very similar to what we have done before. Time is kind of warming up question, so let's do it. A dancer jumps vertically upwards with an initial velocity of the 4 meters per second. Assume that dancer's center of the mass was initially 1 meter above the ground and ignore the air resistance. So what I recommend for all these times, draw a diagram. We have the dancer, his center of the mass is 1 meter above the ground, and he's jumping vertically upwards with the velocity of the u of the 4.0 meter per second like this. That's a given. Now, we are dealing with the vertical motion, so even though it's not really given, we know that A or AY would be minus 9.8 meter per second squared, or the 9.8 meters per second squared downward all the times too. So, and let's do the question A. How long did the dancer take to reach her maximum height? In the case of that, we have to make at max height. What we know is the final velocity of the y would be 0. This means this is coming out from u plus at from the motion equations that we learned today. I mean, not today, sorry, like from like many months ago. So AY and AY goes together like this. So in the case of that, we know the UY is 4. AY is minus 9.8. Simply just substitute the values. So we know 0 is equals to 4 plus minus 9.8 and t. That's giving you the time taken for the whole motion itself. So you will get the 0.41 seconds for the first one. Kind of warming up question, as I said, so just, it's not so difficult to do it. What about B? What was the maximum displacement of the dancer's center of the mass? Maximum height or maximum displacement we have to find. So we know the U is that and all is given. So the motion equations, V squared equals to U squared plus 2AS is what I prefer to use, rather I use the time. U is at the maximum height 0, U is still 4 square, plus that 2 times minus 9.8 times S like this. Then you get the S, the displacement would be 0.82 meter upwards, which means the center of the mass starts from 1 meter will be displacement, by the way, displacement would be only 0.82 from the starting position to the initial, the final position in that case. C, what is the acceleration dancer at the top of her jump? Joseph, what would be the jumper's acceleration at the top, at the maximum point? What would be the acceleration? Good, good. It's always be constant acceleration. So there will be no change to constant acceleration. That would be minus 9.8 meter per second squared, or write it down as 9.8 meter per second squared downward. Easy. D, calculate the velocity of the dancer's center of the mass when it returns to the original height above the ground. Now, we may use an assumption, but let's actually solve that using some and prove that in the calculation part. So what we know is if the jumper jumps high in 1 meter and coming back in the same height, guys, what would be the change in velocity sorry, change in this position or displacement. It's always mean when the final position minus initial position that we're given. So in the case of this, we know that will be 0 because it's basically coming back in the same starting point. So that is what? S is equals to ut plus half at squared here like this. Or we may use the 0 for some of the formulas too. The v squared equals to u squared plus 2as. So what we can do is we can substitute the 0 into the 2as part. It's giving that therefore v squared equals to u squared value. What do we know? V is then equals to square root of the u square. That is giving you the square root of what we given a 4.0 square like that. Then you're to get plus minus 4.0 meter per second. Now from here, as we know that the initial velocity was 4 meters per second upwards, and what we know from the direction of the final velocity is downward, therefore the final velocity is the 4.0 meter per second downward. Is the final answer for this. Okay, warming up question basically. Now, could you try for question 4 then please? So 1.3 on page 4, give you about 2 minutes. Don't worry about the drawing the scale diagram. Okay, ignore that one. Just calculate how far. Yep. Oh, I only have one, but yeah, we can use it for now. So 1 more minute. Okay, so let's start from what we have given from the information there too. Again, pretty straightforward question. Just need to figure it out what information's hidden and given at the same time. We're dealing with the vertical motions and we are dropping, the helicopter dropping something down. So initial velocity is 0. That's one information we're given. Acceleration of the vertical motion always be on the earth is minus 9.8 meter per second squared. That's not too bad. Now displacement would be minus 100 meter. Okay guys, did you check this one? Did you put these information in your working outs? Okay, the reason why the displacement is a minus 100 is it's always be a final minus initial. So that's from the final minus initial, which is 0 minus 100 giving you the minus 100 meters or 100 meter downwards. That's a kind of basic for year 12 physics for now. So what do we need to do? You can use the S equals to UT plus half AT squared for your formulas. As we know, U is a 0, simply giving you minus 100 is equals to minus 4.9 T squared here forms 2. Then T would be square root of the square root of the 100 on 4.9. That will giving you plus minus 4.52 seconds. But in times, we only consider the positive times. Therefore, the time taken is 4.52 seconds only. In 2 sig figs or in a sig fig's not really given, so I just take that in 3 sig figs in that case. Not bad, okay. Next one, B. Calculate how far from its original position to the package has fallen after 0.5 seconds, 1 seconds, 1 and 2, etc. So let's go up to around 4.5 seconds because that's the time it's dropping down. The formula that you have to use for that is S equals to UT plus half AT squared all the ways. We can simplify that UT to the 0, so S is always be half times minus 9.8, that times T squared values. Then you just need to substitute the values in, use a calculator again and again and again. So for the displacement down, or vertical displacement, it would be 1.2 from falling down and followed by 4.9. Keep going on that, you got to say 11, see that 20 around, 13.1 in 2 sig figs, and 44. 3.5 would be 60s, 78, followed by the around the 99. So telling you that it's getting actually faster and faster as the time taken is the same time. You can see the difference between those getting increased as well too. That's what we learned as the acceleration. That is change in velocity values as well too. Not too bad. It's a bit like warming up questions as I said. Now, what about this one? Imagine the helicopter described in class exercise 3 is not stationary, but is flying at the slow and the steady speed of the 20 meters per second and is 100 meters above the ground. So what that means is before that 1.3, this helicopter was stationary. Now this is moving forward with the 20 meter per second. Alright, then it'll still be 100 meters there. So calculate how long it takes the package to hit the ground as well too. Now, guys, I want you to have a think about this one in here. If the helicopter moving horizontally in 20 meters per second, what would be the acceleration in the horizontal section? It would be 0. Good. Now you are good to go for the year 12 because you understand there will be constant velocity, constant speed due to that no acceleration horizontally there. But we still have AY, which is the vertical acceleration of the minus 9.8 meter per second squared like that too. Now have a think about meaning of the AX to be 0. This means that if the UX is 20 meter per second, the final speed also be the same as the 20 meters per second as well too, because there is no change in velocity. We can use the formula if you like to, but it's going to be the same result as well too. Okay, so what happened if that's dropping the puzzle from the 100 meters there? What we are expecting is the puzzle was moving along with the helicopter with the 20 meters per second forward. So as it has some of the forward motions, it will be moving as this, forward, still as in the time of that when it's dropped. At the same time, it's getting acceleration going downward like this. So by the time the particle will be moving still forward, start getting increase, and we get same and goes like that. Making this kind of be some sort of the arc or parabola, or even we call the projectile motion, as you can see from that. Yeah. So that's basically what happens to, like, if you think about it, like, we're dropping something, it's going like in a projectile like this. But one thing is, we know that AYX is 0, so we can't really find the time from that given horizontal motions. Instead, we know the vertical motion, AY. Okay, and we also know initially the vertical acceleration, vertical velocity was 0 as well too. Combining all that and SY, which is a vertical displacement, would be something known, that would be same as the minus 100 meter, as the previous, like in the question as well too. So this SY, I just put the Y for the kind of differentiate to the vertical to the horizontal here. Same as UYT plus half AYT squared here forms 2. What do we know? Minus 100 is same as UY 0 minus half of the 4.9 T squared like this. Therefore, time would be same as the one that we had before too, would be 4.52 seconds or 4.5 seconds in 2 seconds. So whether the helicopter is moving forward or not, the time taken for the particle to drop from 400 meters would be the same, which is 4.52 seconds then. Because there's no force applied from the horizon and the force from the horizontal vectors too. B, what about the range, the package? Now, what do you mean by the range? Range means that the horizontal displacement or the distance. Height is the vertical displacement. So the way we can find that range is basically Sx. Joseph, what's the formula for the S again? The displacement? S equals to? Ut plus half AT squared. So shall we just put the X in here to differentiate in here? But what do we know? We know that acceleration on horizontal is 0. So this just simply giving you the range is found by Ux times the T like this. This only be possible because when we know that there is no horizontal forces or the acceleration applied. From here, then what we can do is Ux is given as 20. We found that out, the time 4.52 seconds. So therefore, the range would be times these two values, you would get 90. Around 90 meters in 2 seconds. Does that make sense to all? Okay. So this is an introduction of projectile motion we're learning in year 12 now. What we now be able to see is this. This is what was proposed by the Galileo as well too. Galileo suggests that whenever we have a projectile motion look like that, okay, there is the combination of the horizontal and the vertical factors, and those are working simultaneously. Which means that they're working in the same manner, they work in the same time, in the same frame, but each of those will affecting the motion kind of separately. What does it mean like affecting separately? The horizontal motion will decide the range, how far we'll be moving to. Vertical motion will decide how long as well as how high we'll move on to. This is known as the projectile motion. So to understand that, we have to actually learn about this. Let's move on to the page 7. Some terms there too. So it is given that essential mathematical skills. As I said, range is known as horizontal distance or the displacement. Write this one down as Sx, like this please. Height is known as vertical distance, also known as Sy here like that too. As we discussed that, at maximum height, the final velocity on the vertical final velocity is always be 0. Easy. Air resistance is usually ignored unless they mention the question. And remember, in the question ask a velocity, you must talk about the direction. Okay, don't forget that. There's a common mistake made by a lot of students. You shouldn't make that mistakes. So let us consider about this here. So going back to this question then, going back to the question that we had, the helicopter questions. What are big guys then? What velocity? Is actually question D. The final. The velocity. So let's have a think about like in the separate motions too. For horizontal, let's separate that. X and the vertical. Y for this helicopter motion state, which is 1.3 again. 1.4, I guess. Okay. Damn it, what would be the final Vx for the parcel, which is dropped from the helicopter, which is moving in 20 meters per second?
90 meters divided by the time.
Vx is equals to, remember there is no air resistance, there is no net force on horizontally here, there's no force applied, so the velocity will be constant, which is 20 meters per second. This is an easy trick, 20 meters per second, as the acceleration is 0. For the horizontal sections only, by the way. Pretty easy, yep. Now, let's find the vertical velocity. How do you find the vertical velocity? We got to do the same thing. Vy equals to uy plus half uy plus at. Here like this too. What do we know? U is equals to 0. A is equals to minus 9.8 in the vertical motions. Time taken, we found that as 4.52 like this. So the vertical motion wise, you would get the minus 44.1. The meter per second, like this. That's pretty fast speed, means that that's a 44.1 meter per second downward. Easy? Up to here. So, shall we draw that in the vector diagram then? Vector diagram as in this. We have a horizontal velocity, which is moving in to the right 20 meter per second like this. We also have the vertical velocity, which is going downward like this. I need to draw that longer. 44.1 meter per second like that. Okay, if I want to know what happened, have a think about what we learned in the module 2, or the module 1. If these two vectors are working same for the one object here, simultaneously it gets pushed forward and going downwards too. So the resultant vector, as we learned, head to tail and tail to head. This is the resultant vector, find the velocity then. And it must be the right angle triangle with the having angle theta here like that. So how do you find that the V? We can use the basic Pythagoras. V is equals to square root of the 20 squared plus 44.1 square like this. Then you get the final velocity value, which is 48.4 meters per second. Make sense to all? Okay. What about the angle? We can use the trigonometry here again. The angle is same as tan inverse of the 44.1 on 20 like this. Then you get the angle that is 60 rounded to 66 degrees. So your final answer needs to be written as this. The final velocity is 48.4 or 48 meters per second at the 66 degree under or down the horizontal. Or below, I should say, under or below is the right terms to use. Does it give you some sense about this? Okay, this is what you need to write it down in your final answer. Pretty good, not bad. Okay, not so. As I said, like I could try to go easy on this because I know you just finished your yearly. Your brain's probably just cooked up. So, I mean, this shouldn't be too bad to understand. And this, I'm just adding some extra stuff on the top of the what you learned in year 11, module 1 and 2. So let's talk about these trigonometry reviews and all that too. So this is how we use it. So let's go back to the page 1, please. Page 2, I guess. Page 2, please. Let's highlight that in here. And this is the terms that you actually need to understand as well as memorize. According to the Galileos, the motion of the projectile can be regarded as two separate and independent motion. Please highlight that, and it's been highlighted. Highlight using the highlighter. Two separate and independent motions. What does that mean? We have two separate horizontal and vertical, and those are independent. They are not affecting each other. And they're superimposed upon each other, and the first is a vertical motion, which is subject to the acceleration due to gravity, and second is horizontal motion, which is experience no acceleration, if there is no air resistance. These two motions can be placed within that two-dimensional frame of reference using the y-axis and vertical motion and x-axis, just like what we have gone through like this. Important thing is there are two independent but separate like motion factors. The vertical factor, or like velocity factors. So going back to the page 2, let's answer this question then. Let's actually do the in purpose then. Can you divide the grid into 2? So what we do is divide it like this, here like that. We got to construct into the two different formulas. So one is for the horizontal, which is x. One is for the vertical, as if you were making some sort of table there. Okay, let's start from the horizontal. At the horizontal, what we know is ax is equals to 0. That's what's given. So, how about we substitute that into the general motion equation given? So, Vx is equals to ux plus axt. But what do we know? As ax is equals to 0, it's just becoming into ux is equals to ux like that. Okay, this is how we say write it down the modified motion equations from that, as understanding the ax equals 0. What about the second one? Sx is equals to ux plus uxt plus half axt squared. But what do we know for ax? It's a 0, so I can ignore that at the back. It's simply giving you that Sx is equals to ux and t, and this is known as the range all the times. The last one, Vx squared equals to ux squared plus 2axsx. As we know, ax is 0. The last one is ignore that too. It's bring back into the what we had initially. Okay, so two important, like only, but we get these information from the horizontal axis. Make sense? Cool. What about verticals? At the vertical, ax is not, ay is not 0, it is minus g, or minus 9.8 meter per second squared. That is also known as the gravitation acceleration due to gravity. So the first equation, v, y, the final vertical velocity is same as uy plus ayt, like that. But we can remodify it into vy is equals to uy minus gnt, like that, or 9.8t. Secondly, sy is equals to uyt. Now, let's substitute the minus g straight away in here. Then you'd get half minus g on 2 t squared forms like that. Or 1 over like a gt, it's the same thing. Okay, equation 1, equation 2. Third, vy squared is equals to uy squared minus 2gsy, equation 3, the third one. So we simply just substituting the different kind of modified value into the motion equation formulas, and remodified it into the different, like they suited into vertical and horizontal axis. Not too bad up to here. Okay, so let us think about what does it mean by that. Okay, let's do that. Assume that we have a ball. Need to draw in the bigger scales, that is. A ball is going in here. Okay, initially the ball is launched in this angle. Let's say that's around the 60 degrees there. Okay, and giving you that amount of u of the, say, 10 meter per second, like that. Okay, And this is things that we have to learn from the year 11, module 1 and 2 again too. Whenever we're dealing with a diagonal vector, whether that is a motion, that's where we have velocity, acceleration, and force, whenever we have diagonal vectors, we are able to construct them into the two different components, x and y. So this is having component x and y like that. Okay, redrawing the vector diagram, it will look like this. We have 1 and 2. So 10 meters per second there, and that's giving the 60 value here. Then, outer code this vector is for the horizontal, that is for the vertical. So, if that is you have to write it down as this is uy, and there's a ux value here like this. Okay, now we're moving on to the page. Sorry about it going up and down, but I'm just simply talking about what we have in page 8. Okay, from the using the trigonometry understanding of the right angle triangles, uy from the given is same as u sine 60 or sine theta. So that would be same as 10 sine 60, like this. In the case we have a ux, that's a cosine, that would be same as u cos theta, same as 10 cos 60, forms like this. Okay, easy question. So, and then if we need to find the actual velocity here, we can use the Pythagoras, or you can use any trigonometry rules too. Not too bad. Okay. So in the case of we have an incline of 1.5, we can do the same thing. But let's have a think about it before we move on to 1.5 there too. The motion of the ball, if we projected something in that direction, have a think about it. If we're going into these kind of creating this kind of motions. Same as that you're kicking a ball, like that. Okay, so what I'm going to use is, I'm going to use green for the verticals and blue for my horizontal. So initially, let's have a think about it in here. If we have that value here, initially we had this, ux. Okay, now, and we also had a bit of like the uy goes like that. Initially, that's what's happening. Can you see that? What's going on in that? Now, as the ball is moving up to the maximum, moving towards the maximum height, Joseph, what do you expect for its horizontal velocity? Horizontal. No, horizontal. There's no acceleration. So it would be same vector, which is a Vx, same length. Are we expecting that vector length will be changed throughout the journey of the balls? It will be the same. So it's still going into same like this. Okay, it's going to move in, define the velocity x, which is same as the ux values, as we discussed that in horizontal motions. But what happens to the vertical vectors? As the ball is reaching to the maximum height, starting from the max uy, it's getting decreased, go like this. And then at the maximum height, we don't have a uy. At the vertical height, we started getting this, and goes like that. So drawing the vectors in between them, the resultant vector in between those horizontal and vertical vectors, this would go like this, go like that. There's nothing, this goes forward only, which is the same direction, going in this direction, and going in that direction like this. Okay, this is only because of that there's only one acceleration. Guys, this is something very important. Throughout the journey of the projectile motions of the ball, there's only one acceleration applied, which is the acceleration due to gravity vertically downwards. There's no acceleration forward or backward, only one acceleration of going downwards too. Which is kind of evident from there's no change in your horizontal velocity at all. Does that make sense to all? Okay, that's how we can think about it. I mean, there are a lot of questions coming out of from too, but we're going to do some exams, problem solving with using this. Okay, so let's try this question there. 1.6, page 9, please. A stunt driver is trying to drive a car over a small river. The car will travel up a ramp at an angle of 40 degrees and leaves the ramp at traveling at 22 meters per second. The river is 50 meters wide. Will the car make it? So let's draw it. What's happening? So we have a river which is about like 50 meters wide. There's a stunt driver, like there's a wreck here, and the angle is 40 degrees. A car is going up in field like this and try to jump over the river, but we don't know yet. So what we're given, the car has this kind of vector of the initial vector of the 22 meters per second with the angle of the 40 degrees that here like this. Okay, everyone got up to here? I just rewrote what the information we're given. So let's start from here. This is kind of, I give you some step-by-step guideline in here. Step 1. Always, I mean like in most of the questions, find the components, the x and y components of the initial, the velocity. So what are we given? We have given 22 meters per second. So that's the vector we have, which means we have the ux and uy like this, and 40 degrees there. Okay, then what do we do from here? Well, we can take as uy from this right angle triangle is, using the sine, 22 sine 40. Ux would it be 22 cos 40. I just leave that in exact value for now. That's the first thing we have to do. Step 2. After that, we may need to find the time taken, but it depends what we have to find in here. We have to find the range. To find the range, we need to know the time taken. So, to find the t, the time taken, use the vertical component. Especially like this here. Guys, have a think about it in here. The car jumped from this state and came back to the same state. So, David, what would be SY of the car? Car jumped.
2.2 sine.
SY.
Or S1.
There are two methods. Final vertical displacement. The car jumped up and came back to the starting point. What would be the final vertical displacement? Displacement. Zero. Why is that? The car jumped up but came back to the same initial point. So it'll be zero. I mean, there's no change in the position of the car vertically. There's only change in the car's in the horizontal position. That this is method 1. So using that sy equals to 0, you can take uy is equals to uyt plus half ayt squared. And they show the substitution values here. The uy is 22 sine 40 times t plus half of the ay is minus 4.9 t squared is equals to 0. You can put the t out, then you'd get 22 sine 40 minus 4.9 t, that is equals to 0. The t is either be 0 or 22 divided by 4.9. That's giving you roughly about, I think giving you about 2.8 seconds if you found the value. That's the first method. And I prefer this method all the times too, but it's also good to know the second method to find the time. Okay, Joseph, have a think about this situation. Can you think about this here? The ball was projected and came back in here like this. If we know the time to go to the maximum, from 0 to the maximum height, what would be the time from here to there?
Same as T.
Same as T1. It would be same as the T2 would be the same. Which means that if we can find the time taken from the 0 to the maximum height, times 2 of that will give you the total time of the flight. In that case, we have a same like the final velocity, final displacement. So for that, what we have to use is this. At the maximum height, use the low at max height. The Vy is equals to 0. This is giving you that Uy plus Ayt like this. Showing the substitution of this is 0 is equals to 2 into 22 sine 40 minus 9.8t. Then t would be simply 22 sine 40 divided by 9.8 like that. Then this will be giving the roughly about 1.4 seconds there. Okay, remember that this is a time, same as time taken to reach the max height. But isn't that same as that time taken, say, from the max height to the ground again? Therefore, the total time taken would be 2 times 1.4, giving you 2.8 seconds as well too. You can either use any of those methods too, but as I said, I prefer using the method 1 rather using the method 2. I explain you why when you're doing the next question. Okay, so we got the time taken. So step 3 for this question, step 3. What do we have to do? We have got to find the answer, or find the Sx using the Uxt. So the range is would be Ux, which is given as what? 22 cos 40. That times that, I have to use the blue, sorry. Sx is equals to 22 cos 40. That times the total time taken. We found that in any of those methods, it would be 2.8 seconds. It will give you out the value of the 48 meter. And then answer back to the question. So will the car make it? Will the car make it? I mean, the river is 50 meters wide. The stuntman is jumping 48 meters. So it's like 2 meters short. So the car will not make it. As 48 is smaller than 50, the car will not make it. Okay, so this is how we use. Okay, in physics, this is how we use it. Now, the reason why I say physics is you've got to do the same things for projectile motion in Extension 1 Mathematics, Year 12, Mechanics. In there, you've got to do the Newton's last one, the vectors. In mathematics, they give you like some projectile motion formula. And a lot of times, students just using the formula to memorize that and they're using the values too. Now, I don't recommend to use that formula in physics. First of all, physics teachers seeing that formula in physics exam, we hate it. We want to see the good working out look like this. Because I know the formula is really handy in terms of that's giving you the formula of the range straight away. You can find that. But we're not going to learn about that unless maybe like a little bit later on, maybe next week a little bit of this, but we're not going to spend too much time on that projectile motion formulas. Okay, now could you try 1.7 please? Challenge that. Give you about 2 more minutes. How'd you go?
C and D.
Okay, let's see. The C and D and everything too. So it's given. The archer releases his arrow from point 1.5 meters above the ground at the angle of the 10 degrees. If the arrow has the initial velocity of 30 meters per second. So, okay, let's draw that diagram because what the question A is asking too. We have an archer, so doing this, okay, doing the archeries like that. Well, can't draw the straight line. Like that. It is given that this arrow is launched and make a projectile motions like this. Note that it's 1.5 meter above that. So when, have a think about it here guys, okay? When the arrow reaches the bottom of the ground, it's actually 1 meter down from the starting point. Okay, not a perfect diagram, but it's kind of relevant. 30 meters per second for the initial velocity is given as 2. Angle is given as 10 degrees. So let's draw the vector diagram. I would love to see, I love to draw the vector diagram all the times. We're given that 30 meter per second, that's a U, which has these two components with the 10 degrees and the right angle triangles. So UX and UY. This is the first step, every single thing you have to do. UX is from this right angle triangles, 30 cos 10. From this right angle triangle UY, that will be 30 sine 10 AS2. Not bad, okay? So that's the starting point. A is done. B, the maximum height of the arrow above the ground. So at max height, as we did, max height, what we know is Vx is equals to 0. Using the information in here, as we know, Vx is equals to Ux plus maximum height of the arrows 2. So we have to use this. V square x equals to Ux square plus 2AXS, like that. S, oh, sorry, not the x. What am I talking? Vy is 0, sorry, my bad. Vy square equals to Uy square plus 2AYSY, like this. This is the formula that we can use. Then what we have to do is, we can just show this substitution, all that. Vy 0 and Uy 30 sine 10 square plus 2 times Ay, that would be minus 19.8. For the 19.6, sorry, 19.6 times Sy value here. So you can find the final velocity, sorry, the maximum height, 5.3 meter. But that this 1.3 meter from the starting point. The final height is therefore 1.3 plus 1.5 for the height of the launching, giving you 2.8 meter. This is the final answer. Not the 1.3, 2.8 is the final answer because it will evolve that graph from 2.8 meters, not 1.5, 1.3. Good? Let's do the range. Joseph, what do we need to know for to find the range? What is the formula of the range? Sx is equals to? UXT. Now, do we know UX? Yeah. Do we know a T? Are we given T? Are we given T? I don't think so. The key is not given. So this is the before to find the range, we have to find the time taken. Now, this is why I prefer using the method 1. Let's have a think about Sy when the arrow reaches the ground. Just what would be the final vertical displacement?
0. Wait,
negative 1.5 meter. Because it would be below the 1.5 meter from the starting point. Then you got to use this. This is same as what? Uyt plus half Ayt squared forms as 2. Let's rewrite that value again to 1.5 is equals to Uy, which is the 30 sine 10 times the t minus half of the AY, which is 9.8, 4.9 times t squared like this. What do we do from here? I'm going to move everything to the other side, so give other side of it, it gives you 4.9 t squared minus 30 sine 10 t minus 1.5 is equals to 0. Guess what? I'm going to do a quadratic from here. Yes? Yes, that's year 9, year 10, by the way. You should be able to do it. So, quadratic. X is equals to minus b plus minus root b squared minus 4ac over 2a. Do the same thing. Minus b, 30 sine 10 plus minus 10 sine 10. Sine 10. B squared, the 30 sine 10 squared minus 4a, 4.9 times minus 1.5 divided by 9.8, which is 2a2. Looks to do. That's all you need to do, guys. Okay, and then what do? You gotta do like in the values in. Use your time taken for everything. I don't know. Like, can I use my calculator for a while? Okay. Yeah. Put everything value here. The 30 sine 10 sine 10. So that square minus 4 times 4.9 times minus 1.5. Put in your calculator, square root of that. Okay, and 30 sine 10 minus that value divided by 9.8. Oh, crap, okay. Have to do it again. So that, square root of that. There, okay, what I do is I'm going to add that 30 sine 10 and divided by 9.8, then you have to get 1.29 around the values. No, get the different values. Shall we do it again? 30 sine 10 square minus 4 times 4.9 times minus 1.5, square root of that. Okay, and plus that 30 sine 10 again, divided by 9.8. Yeah, I get 1.2988 seconds. Yep, it should be that value here. So we got the now time taken. We now know like the ux value. Therefore, the range x equals to uxt. From that, 30 cos 10, that times that time 1.2988. So answer times that 30 cos 10, you should get 38.37. So given the sig fig values, is roughly about 38 meter in 2 sig figs. Okay, this is the first method. Again, you can use a second method in here. It's going to be a little more complicated. It's actually more complicated than you thought from here to there too. But now I want to stick on to this formula, this method. This is actually easier than the other methods. Okay, now D. Let's find the final velocity then from here. What do we know? The Vx is same as Ux value. That's given that as 30 cos 10. That's it. For Vy, we have to find a different value here is equals to Ux, I keep saying Ux, Uy plus Ayt. Uy value, they were given that 30 sine 10. Plus that, minus 9.8 times that time taken. Total time we found it in from question C was 1.2988. So 1.2988 or 1.3 approximately. It's got to be a similar value too. So putting all the values in, about 9.8 times 1.2988. Okay, 30 sine 10 minus that. You get minus 7.52 meter per second. And it is natural to get the negative value because the vertical velocity must be going downward like this in 7.52. And horizontal will still be 30 cos 10. That's the final vector we have to find. So final vector is using the Pythagoras, using that the v is equals to square root of the 30 cos 10 square plus that 7.52 square here forms 2, so that square plus that 30 cos 10 square and square root of that, you get 30.485 rep per second in 2 sig figs. You also need to find the angles in here, that angle theta. So angle is tan inverse of the 7.52 divided by 30 cos 10 in the value 2. So 7.52 divided by 30 cos 10 and tan inverse of this, you get 13.86, so roughly about 14 degrees. Therefore, the final velocity is 31 meters per second at the 14 degrees below the horizontal. This is the final answer for the question. Whew, complicated. Okay, it gets starting a little more complicated from this section here. I know that. Okay, so it looks. I started from really easy one, and then draw out to. Oh God. Okay, but again, in terms of like in some explanation, in terms of like expression in here, you learned that in the vector. You learned it in module 1 and 2. You also learned that in like a vector diagram. Okay, only thing that is it's a new in this chapter is we have to divide the velocity into the horizontal and vertical. Even that, we kind of did that. Okay, probably the one is that the more complicated motion equation do you have to use. And this is what I'm saying, like if you can't do like in module 1 and 2, year 11, don't even think about doing the module 5 in year 12. You can't do it. I mean, simply you can't do it. People who hate the quadratic, I'm sorry, but it's a win-win. You know, you can practice the quadratic in year 12 physics. You got to use that, all that too. But for now, that's how we solve the question. And this is one of the easiest questions you can get in year 12 standard for now. Oh, come on, not too bad. It looks messy, looks really complicated, but it's actually easier than you thought. So it requires a bit of practice to make it perfect. So before we do some more practice questions, how about we have some break? Okay, we're going to move on to some try yourself questions after that. Question 1 from here. I hope you go through some of the questions by yourself and then have a think about how you're going to deal with that questions. 1, a cricket ball is drawn at an angle of 50 degrees to the horizontal at 50 meters per second. Calculate the time it takes to return to the level of which it's drawn. It's pretty easy, one way, because I mean, I like to start with the diagram all the times too. So we have cricket ball 50 meters per second, and we have 50 degrees there, come in and goes coming like this. Okay. What we have to count from here is the time. Is we can't really use the horizontal factors. We only need to use the vertical factors to count that too. So you're given the initial of the 50 meters per second. So draw the diagram, the vector diagram. It look like this, 50 degrees. And that, you will see that uy, we found from the right angle triangle, would be simply 50 sine 50 like this. I don't really need to think about like, the horizontal because we're not going to use it. Instead, I'm going to just use that one here. Time taken to return to the level means that it came back to the same level. So the information is kind of pretty much given. Everything is required. We have sy is be 0. AY still be minus 9.8 meter per second. And UY would be 50 sine 50, like this. Combining all the factors over here, then you would get SY equals to UYT plus half AYT squared. Substituting the values in, then you would get 0 is equals to, given that 50 sine 50, that T, sine 50T, minus 4.9, the T squared, giving you the T 15 sine 50 minus 4.9 T like this. That would be 0. T would be 0, or given the value here, so does anyone calculated? 7.8. Yep, you would get 7.8 seconds. So we have to take this time for the total time taken. And mathematically, as I said, and logically, it makes sense. The only time we have, the two times we have this displacement is when the ball is not launched, which is the initial point at 0 seconds, or when the ball comes back from the return journey. Okay, that's what we call question 1. 2, calculate the distance we travel by the ball if it was struck on angle of 40 degrees from the horizontal at 10 meter per second. Okay, the distance traveled, it's question asking you to find that range, not the vertical displacement in that case. So drawing the diagram here again, question 2, we have the ball struck at 10 meters per second with the angle of the 40 degrees here like this. Drawing the vector diagram of this, we may need to find both of those ux and uy values. Uy would be 10 sine 40. Ux would be 10 cos 40 here like this. Okay, now to find the time taken and for the range, we have to use the vertical displacement, just like what we have done in question 1 here like this too. So you're given that. It's coming back to here. The question asking struck at an angle and horizontal here. So we are assuming that it's struck in horizontally and came back to the same displacement of the vertical displacement. So Sy would be 0, Ay from the minus 9.8 meter per second squared here like this form. Uy is given as that. So from here, Sy equals to Uyt plus half Ayt squared. Always use the vertical components to find the time taken. That would be 0 equals to 10 sine 40t plus that minus 4.9 and t squared that too. So t would be, if you solve the questions there, you would get the 10 sine 40 divided by 4.9. That would be time taken. Okay, I just leave that an exact value for now, for the more exact value later on too. Then from here, to find the distance or the horizontal displacement or the range, you have to do that ux times the t. The ux given at 10 cos 40, that times that 10 sine 40 divided by 4.9 here forms as well too. So I don't know, I don't have a cursor, you can be my calculator today. Calculate the values for me. 10.1?
10.6 here, so it's actually 10.0.
10.0.
When you
Using the exact values?
using the exact values it's 10.0, but when you
Using the rounded value,
turn
10.1.
that into 1.312,
Yep.
it's 10.1.
Use the exact values. Okay, it'll be 10.0, roughly about 10 meter then. In a sig figs error, in 2 sig fig it'll be 10. How many sig figs have we given? 3, 10.0. Yep.
In an exam, do we have to do it like this? Or if we turn that t into a decimal of 1.3? And get a value?
You can find the values and you can substitute the values in, but in your calculation for the final answer, try to use that working out.
Doesn't 10.049
Or for 9,
10.04906.
that's rounded up to 10.0.
Yeah, if it's just...
Doesn't
Good.
5 round up to 1?
No, there's 4.
4, 9 at the end.
4, 9, yeah, we only count that one.
The 4 turns into a 5.
No, it doesn't turn into that.
Only if you count from
The one after that.
So when you're calculating for just the one right after, you kind of ignore that completely.
If you have that value, we only counted the 4, which is right after the sig fig we want to count. That would be 10.0 meter in 3 sig figs then. As a 4 is less than 5. We don't count the 9 in here because that's rounding up twice. We only round it up once if you have one value straight out, value after the next to that value. Okay, that's for question 2. Question 3. A shell from the gun started on its way at 350 meters per second at an angle of 10 degrees from the horizontals. Calculate the greatest height to which the shell would rise. So pretty easy question that. So we have the 3, sorry, that's too big for 10 degrees. We have 10 degrees there and 350 meters per second squared like that too. Always start with the horizontal vertical factors there. So vertical factors, all the component, uy would be, if that's u, that would be 350 sine 10. That's what you get. Now, what we have to consider for the maximum height, at the max height, always the Vy would be 0. From here, what do we need to find? We have to find the value of the extra height. We have to find that Vy square equals to uy square plus 2aysy, the forms 2. What do we know for the Vy is a 0 at the maximum height. Uy is given as 350 sine 10. I mean, that's what I prefer to put in my working out. Rather than you find the decimal point at uy values, it's much better to forming it, like, and use those exact values later on to avoid any like specific errors. So that is same as ay is minus 9.8, so plus that 2 times minus 9.8 and times sy like that. So sy, moving to the other side of that too, is the same as that, 350 sine 10 square divided by 2 times 9.8 like this. Okay, what do you guys get for the vertical displacement then? 188.46. Shall we round it up to the sig fig value? You're given that in the 3 sig figs. The 10 degrees, we're going to count that as 10 degrees and 3 sig figs too. So round it up to 3 sig figs. Same for this, I mean, this is the same as 188 meter above the horizontal, the ground, in 3 sig figs. That's how we can write the final answers following to the sig figs. Good? Okay. For a rifle bullet aimed on angle of the 15 degrees from the horizontal was in the air 18.5 seconds before falling back to the level from which it was fired. Calculate its original speed. Ooh. Okay, so let's write it down what we give it. So we're given that it was aimed to get 15 degrees and following that, time taken is given as 18.5 seconds there, and it was in the same level to the fire to its original speed. We have to find it in here. So we don't know any of those values here. U is only be given. So what we can tell is uy would be still just u sine 15. Ux would be u cos 15. That's all we know for now. Okay, but we also know that one thing here, the sy would be 0, 2. All right, then time to use those values here. Sy is also equals to uyt plus half ayt squared. You can get the t out and basically, so write it down. 0 is equals to u sine 15 plus the half ay, which is, I just write it down, minus 4.9, the t squared like that, the t. T can be cancelled out from the 0, 2. So now have a think about it in here. To find the u, we can do that by moving the other side of 2. The t will be given u sine theta, the u sine 15 is equals to 4.9 t. So from here, leaving the u in the subject, 4.9 t is equals to u divided by that times a sine 15. As we give it in t, 4.9 times 18.5 divided by sine 15. Yep, so what about the value? 350.244. Now, check the sig figs, we have a 3. So it'll be 350 meter per second in 3 sig figs like this. Okay, again, I'm using the same techniques to always try to use the vertical components to find the time taken. That's the kind of techniques you can use. Same in here. Bit methy, but not that much. 5. The muzzle velocity of the mortar bomb is 100 meters per second. Calculate the angle of the elevation of the barrel to achieve a range of 500 meters. So Again, let's draw that too. We have the velocity of the bomb is given that as 100.0 meter per second. That's u. And we don't know the angle, so leave that to theta and the right angle triangle here like this too. So it's always start off with the initial one. Uy would be 100 sine theta. Ux would be 100 cos theta value like this. Everyone got up to this point? Okay. Then what we also know is that it is flew for the range of the 500 meters. So xx is given as 500 meter forms like this. Knowing that sx is ux times the t, from here we can get the relation here in terms of t values. Okay. Now t, make a subject t would be same as 500 divided by ux, that is 500 divided by ux, 100 cos theta value. Change that out, we will get the 5 on cos theta. Make the equation 1. Secondly, we can use the independent of the vertical factors from here. So what do we know? We know that from here, sy is equals to 0. Still coming back in the same height. This is the same as uyt plus half ayt squared value here like this too. You can cancel out the t if you like to. I mean, you can surely do that. Uy, substitute value 100 sine theta plus or minus 4.9t is equals to 0 as well too. So make a subject to the t, like in the t is then equals to moving outside, 100 sine theta divided by 4.9. Got it up to this point, guys? Equation 2. So what do we do? Solving for this equation 1 and 2, they make the same. So we get the 5 on cos theta, the same as 100 sine theta on 4.9 like this. Okay, so moving to the other side, 5 times 4.9 is equals to 100 sine theta and cos theta. And you remember from the further tricks? Good for your extension 1 mathematics. It's a math question, by the way. Joseph. Sine theta times cos theta. Actually, I forgot too.
Wait, I should know this. You know I got this one.
I know that. I should know that. Oh, come on. I shouldn't forget that. Ah. No, that was something. Ah. Hundred that and that. Oh yeah, of course. This is need to do half of the sine to theta value. Yes. Okay, it's been a while doing the tricks. Okay, that means that same as the half of that. Okay, 5 times 4.9 times 2 and sine 2 theta. You can find the value. So 2 theta must be sine inverse. We'll just simplify the theta values. Theta is equals to sine inverse of the 5 times 4.9 times 2 divided by 2 like that. Yep. Then what do you guys get? Oh, sorry, the 50. Yeah, that should be that should be 50 sine 2 theta. So my bad. That's divided by 50. Can't do math. Huh? Sine 2 theta. So it'll be sine the 2 theta, or the theta is equals to 5 times 4.9 on 50, and that times that divided by half of that. Sorry guys. Half times sine inverse. I keep forgetting this. 5 times 4.9 on 50, like this. Okay, you can be my calculator after that to find the value.
67.
So angle would be 14.67. And the given sig figs of how many? 5. We have given 4 sig figs. Yeah, that'll be it. Degrees. Looks a little complicated, but I hope you don't have tricks. I mean, 2 theta.
Our math test recently was mostly tricky. So we're kind of traumatized.
Yeah, okay. Sorry to bring that trauma back. But it's kind of possible. Like, it's not really like the typical questions that we get in physics, but dealing with the angles like this, it's kind of, because we're dealing with the tricks. Okay, question 6. A stone was thrown at a distance of 75 meters at the elevation 24.3. Find the original speed of the stone. Okay. So what are we given? Let's have a think about here. With elevation of 24.3 is first things we are given. And the u is not given, but you know the ux and uy can be found by u cosine. Why am I tipping over there? U sine 24.3 like this, and that is same as u cos 24.3 like this values too. And then from here, calculate the original speed, and sx is still be given as 75.0 meter. This is same as that, original speed of the stone, same as the uxt, the values. We don't know the t, so we have to find the t, but we know the u values given of it. That. So t would be the u cos of that, all the values too. We're not really given the value. So that's equation 1 we have to make. Secondly, it was stones are thrown distance of 75 meters.
Could you have the max height by halving the distance for it?
You can. The max height, half in the distance, yeah, you can.
That's what
But it's the same result anyways too, times 2. At the range, sy would be 0, that would be uyt plus half ayt squared. I think I prefer that rather than using the one. It's going to be a little more tricky because we can cancel the one t out. Uy would be then, just leave that as u cos 24.3. And the t, equation 1. That's same as a uy, u sine 24.3 plus that minus 4.9 t like that. That is equals to 0, 2. Making the subject to the t, then t would be same as, moving to the other side, u sine 24.3. That divided by 4.9 is the equation 2 for the t subjects. So in a way of that, it's 75. From 1, I actually need to do that. The t is equals to 75 divided by u cos 24.3 like this. Okay, that is what? So therefore, 75 u cos 24.3 must be same as that value here. U sine 24.3 divided by 4.9. Okay, what we have to find for the question 6, I have to find original speed of the stones. Okay, moving to the other side of that too, I think we are almost there to find the values. So that's giving the u square cos 24.3 times that sine 24.3 as well. It's the same as that, moving to the other side, 75 times 4.9. Therefore, u is same as 75 times 4.9 divided by cos 24.3. You can use the sine rules, doesn't really matter. Or like, either way, you can do that. Times that, sine 24.3. Okay, and then square root of that.
the other method as well?
If you do the half of the maximum height, the time's got to be a little more trickier. You get the square of the times. So what do you get?
31.30.
31.3, sorry?
30.
30. Okay. Given sig figs of the 6, we have given 3 sig figs, same as 31.3 meter per second, like this. Not an easy to consider about how to deal with the questions, but this would be like one of the hardest questions you can get, obviously. In a way of that, using that. It's not really common to use it, but you know, time to time, it's good to know. Okay, let's do 7 for the last question for today. Okay, on the exoplanet Zog, an astronaut fired his slingshot at an angle of the 45 degrees, the stone having an initial speed of the 10 meters per second. The stone flew 25 meters before hitting the ground. Calculate the value g on the surface Zog. Ooh. Okay, I would like to start off with like drawing the diagram of this first. What is going on, and plan before you do something. And then we gotta go through the questions together. Then 7. Give me 1 more minute. Okay, starting from what you're given for the planet Zog, we have the launch the ball 10 meters per second and 45 degrees. So vector diagram shows that uy of 10 sine 45 and 10 cos 45 are given to. Now, knowing that the range is 25 meters founded by u, x, and t, substituting the values here again to the same as the 10 sine 45 times the t values. Then, we don't know actually the t, but t can be calculated by 25 divided by 10 sine 45. I'll leave that at equation 1. So we now have the time taken for that.
Sine. Cos.
Oh, sorry, the cos. I keep looking at the cos and sine separately. Cos 45 and cos 45. Makes sense, okay? For the vertical motions now this is the key point. We got to do the one for the horizontal, one for the verticals. If the ball reaches the same height as what 2, then sy still be 0. The formula for that is uyt plus half ayt squared. And this is the beauty. I can cancel the 1t out, giving you that uy and ay all the values too. So substitute the uy, which is 10 sine 45, plus that, but what we know for the acceleration due to gravity is always be negative value, but we don't know what the g value is. So what I'm going to do is I'm going to put that minus g on 2, the g for that planet, gravitational accelerations, times that t here like this. That equals to 0. You can do the other way around, it doesn't really matter by the way too. Moving to the other side, then you would get the t, make a substitute to t, then t would be 10 sine 45, that times that to the 2 on g like this values too. Okay, that's equation 2. So what do we do? 1 and 2 are the same, so 25, 10 cos 45 is same as 10 sine 45 times 2 over g value like this. Then make a substitute to the g, like into all the values here. The g, 1 over g is, that's time at 20 sine 45. So g is the same as that 10 cos 45 divided by 25 times that 1 over 20 sine 45 like this. Okay, you can cancel 10, 1 and 2 like these values too. Then what do you get? It's a 1045 by the way. Well, actually, 50, 1 over 50 times the root 1045, 1 over root 3. Okay, anyways. Calculator. 1 over 50 times the cos 45, sine 45. Am I right? Hang on. I just tried to do 25g on.
Doesn't.
No. Yeah, I think like the value expression could be wrong. 25g equals to 10 sine 45. Yep. Sorry guys. Okay, that's the other way around. Nah. Can't do math in my head now. 25g is equals to 10 sine 45 times 2 times 10 cos 45. Counting that. So therefore g is actually 10 sine 45 times 10 cos 45 times 2 divided by 25. That should be the right value.
4.
Give me a 4.
Just.
Root 2 on 2, root 2 on 2. Yeah, it'll be 4. Yep. It'll be 4. 4.0 meter per second squared. So it's the value is that actual acceleration value of the g. Yeah, the question asking value of g. So we have to find in it's a 4.00 and 36 fixed then. Root 2 on 2, root 2 on 2, same values. Calculate that. I mean, I don't want to do that because that's not mathematics there too. 25 and that 2 opens up the root. 50 times 200 divided by 25, 4. Yeah, 4 to be the right value. Hmm? You're right, Joseph.
Can you check my working out? I feel like it's right.
I don't know, it's wrong. For question 7.
The minus.
Is that all?
Yeah, that makes a difference. I mean, huh? UXT and T is equals to 2510 sine cos 45. Up to that is right. Cancel out the T. Oh, you substitute the values here straight away. Could be the calculation there too. No. The UX is not. That's a U sine theta. I mean, UX is 10 cos 45. Your Y is 10 sine 45.
Oh.
Yep. They don't cancel out each other. Okay. I hope that's a good introduction of what we're going to learn. I mean, this is tough for these questions. As I said, it's a bit mathy, a bit of like some what we're learning in the extension 1 mathematics later on too, kind of related in that method. Understand we are dealing with the independent horizontal and the vertical components all the times too. So next week we're going to do a little more questions on the projectile motions. So I really wish you to finish these homework, including the HSC questions. Thick, I know, but you got to do it. We got to do it next week. Okay, and we've got to think about how we're going to prepare for those, coming in a year. Any questions for this? Chapter 1, projectile motions. It's okay. I mean, mathy, but I hope you have the hard training from me, like how to deal with those kind of calculations too. I mean, compared to mathematics extension 1, it's actually easier. I only use half of my board. Extension 1 mathematics, I use full and twice time to times too. So compared to that, it's not too bad. Okay, and this would be the hardest question you to get in terms of calculation, to be honest. Most of the calculation would be straightforward.
4 months.
In terms, yeah, I would say so. Okay, if you don't have any question, that's all for today. Exams coming, so good luck. Finish them well. I'll see you next Wednesday.